Hey everyone, In-Game here, back with another video. Today's video I'm going to be talking about my Hack the Box machine Celestial. This will be kind of a walkthrough, but more of a kind of author walkthrough. For those of you who don't know, I'm actually the author of this machine. It was a fun challenge to write. I'm decently familiar with writing CTF challenges. I've hosted a few CTF events, especially throughout my college career. So being able to contribute to the platform that I learned a lot from was an awesome experience. So if you haven't contributed a challenge of any kind to any CTF and there's an opportunity to do so, do it. You learn a lot making the challenge, and it's just an overall good experience. And Hack the Box is a great way to do it. So with that said, this was my first Hack the Box machine that I created. I hope to create another one in the future. But since it was my first, I made a lot of mistakes. And the community has been great in giving me some kind of feedback and some critique about my machine, and that's going to help me be better at designing challenges overall. But even though there's a few mistakes, I still learned a lot designing the challenge along the way. So this video is very long overdue. If you follow me on Twitter, you know this is probably like the 4th or 5th time I've recorded this. I finally got a nice little capture card and microphone set up. So that shouldn't be a problem anymore, I hope. Otherwise, there'll be a very angry follow-up to this that'll be like, oh, this is my 6th time recording or whatever, whenever I finally have it figured out. But hopefully that's not the case. Hopefully this is the final take. So yeah, it is long overdue. Ippsec has, of course, been on the ball and had a video out since it was retired. If you haven't seen his video, go check it out. He's going to do a way better job than I am, despite me being the author. He's got some awesome kind of neat tricks and things that he goes over in his video. So what's going to differentiate this for you guys who are watching this, if you've already seen that video, is that this is going to be like an author walkthrough, kind of like I just said at the beginning of the video. We're going to, of course, hack the box, but also I'm going to talk about some of the decisions I made, why I made them, and also talk about just some of the design pieces or things that you may not have understood about the box from a standpoint of the intended solution. So basically, I'm walking through in depth the intended solution. So enough talking, let's hack some boxes. So I've already ran the in-map scan. In fact, I've already ran an all-port scan as well. It really doesn't take that long, other than the fact that it's got to scan through all the ports. But the only service running on this box is port 3000, and it's claiming to run the Node.js framework. So the idea with Celestial is if that you ran a basic scan, so here's like my initial in-map scan that I ran, you would have shown port 3000 as open. So there's also, you could have done like a service detection, and it would have made a guess at Node.js. This guess is actually correct. It's pretty accurate. When it comes to finding services on a box running on port 3000, this usually is indicative of something like WebBrick for Ruby on Rails, or just like a Ruby instance, or Node. Now there can be other, of course, there's various other different like web framework tools, but those are the two most common in my professional experience. Node.js and Ruby running on port. Node.js and Rails running on port 3000 is most commonly what you'll see. In this case, it happens to be Node.js. All right, so let's go check out what's going on there. It claims to be an HTTP web service. So let's open up Firefox. Also, my IP is a little different. I'm running this in my home lab since I got that author privilege, so I can actually run this in my VMs at home. So my IP is a little bit different. I'm not actually doing this on the Hack the Box network. And it says we can't connect. That's because I didn't specify port 3000. Alright, so many of you, if you encountered this, you're like, oh, 404, that's weird. And you might have started to do something like maybe run a Go Buster or something like that. Well, if you even try to do something like maybe check for the robots.txt, you'll see you cannot get robots.txt, so that's not a route that exists. But if you go back to port 3000 after that point, in fact, let me kind of spoil a thing. So as I go through this, I'm not going to do the full exploitation as if I'm blind. This is just a pure walkthrough with depth. So if you were to check out your local storage, which I wouldn't expect you to do right off the bat, you'll see that there's been a cookie associated with your connection to the site. And if you go back to the root, we see, hey dummy, 2 plus 2 is 22. Well, we know 2 plus 2 isn't 22. It's either 4 or it's fish, depending on who you are and where you're from. But it's definitely not 22. All right, so let's copy that cookie out and check out what's going on here. So I'm going to make a document called cookie where I'm going to keep this. And we see there's these 2% 3Ds on the end. These are just URL encoded equal signs. And now that looks like something we might be familiar with. It looks like a base64 encoded string. So if we base64 decode this into raw cookie, that's what we'll call it, and we cat that out, it seems like it's a JSON string with the username of dummy, the country of IDK, probably somewhere dumb, the city of Lametown, and the num is 2. Well, we see as far as the output on the screen goes, that dummy is our username, and it seems to be being displayed here, and the num of 2 is here, and we're having some weird kind of math problem going on, and it's obviously the math on the server side doesn't appear to be correct. So we can do some things. So let's play with this raw cookie. Let's play with the num. Since the math is wrong, let's see if we can impact from client side those values. So let's maybe change this to leet. All right, 1,337. So now what we can do is base64 encode this raw cookie into our new cookie. And we have our new cookie. Copy that. And refresh the page, see what happens. Okay, it looks like we can affect the input on this page. And we know it's Node.js. Cross-site scripting is probably not going to help us very well here, as it's a CTF challenge, and most of the time cross-site scripting isn't used, although this page is vulnerable to cross-site scripting very easily. A side note, more people should try to integrate cross-site scripting into CTF challenges. It's a very hard thing to do, I know from experience, but that's a challenge to you guys and myself. It makes it interesting because cross-site scripting is very applicable in actual pen tests, so it'd be awesome to incorporate it more into CTF challenges. Side note over. Alright, so we know that's not going to help us very much, but we do know that something's going on here, and we're passing a JSON string, and this JSON string is being unserialized and base64 decoded and unserialized and rendered on the screen, right? Well, if you're familiar with any kind of deserialization or serialization, that's like an OWASP top 10 thing. Insecure deserialization, mishandling the serialization of input is like a standard thing that web app pen testers need to know about and test for. So if we look up Node.js serialization, we see a couple of issues, and down here's a link is exploiting Node.js deserialization bug for remote code execution. Sounds kind of neat, right? Well, many people in the forums on Hack the Box saw this article and were like, this has got to be it. You're almost right. I made sure to go and follow up and clarify. This is not the vulnerability that's associated with my challenge, and we'll look at the server-side code later. I am actually using the serialized module for the purpose of you to exploit it, but the actual vulnerability that you really exploit comes in with some custom code, because the reality is I couldn't get this to work. I don't know if I was using a patched version of this library or not, but I did a workaround just to make things interesting, and also to make it where you couldn't just copy from an article. So a lot of people just ran with this little article and thought, we got it, but then couldn't figure out why it wasn't working, because this is close, but it's not it. But the principle is the same. So essentially, we're going to try to add some JavaScript to our cookie and see if it's going to execute any code. See if there's anything going on. So if you read through this and got a good understanding of how this bug works, then you would have been on the right track at least. You couldn't have copy-pasted and followed right along, but if you had a good understanding after reading this, you'd be on the right track. So with that, let's go edit our num. So an easy way to check for Node.js code execution is simply just console logging. It's very similar to cross-site scripting. I say Node.js code execution like it's a general thing that always exists. God, what a world that would be. No, I mean for this particular vulnerability, the way we can check and see if this code is getting executed server side is if our console log executes and refers back on the screen. Now, it shouldn't execute into our local console. This is not JavaScript like client side. This is Node.js is running as server side JavaScript, which is disgusting in my opinion, but you know, that's a, there you go, that's how you have it. So we wouldn't expect this output to be seen, but we would expect something funky on the client side to appear, right? So we'll console.log maybe elite and write that. Get our new cookie. Go back here and paste in our new cookie and refresh. Alright, so we get console log leet plus console log leet is undefined. So that's an interesting error. So this box wasn't a particularly difficult box. It wasn't. I had originally designed it to be hard, and I felt like this was harder than most of the community did. So this actually got voted into more of a medium to easy tier box, which is actually pretty fair. The only thing keeping you from figuring out how to get around this foothold, and the foothold's the most difficult part, as you'll see later. The only thing keeping you from getting around this foothold is basically paying attention and enumerating for errors. And it's really finicky because sometimes you'll get an error and sometimes you won't. So that's why I've got my handy dandy documentation over here. You may have seen what you just saw, which indicates some kind of code execution going on. We have something trying to be evaluated and it's returning undefined, right? So so you would have either seen that, or you would have seen something like this. This reference error test is not defined. In this case, my string was this console log test instead of console log leet. But it says test is not defined at eval anonymous home sun server.js, which basically says there is an eval at this line in this code. So right away you're like, oh crap, my code's getting ran through an eval statement. Well, yes, even on server side in Node.js, an eval statement does mean code execution. So that was a good place. If you saw this error, that would have been a good hint to start working with, right? There was also another error that might come up that has less information about like the eval specifically, but does tell you that, hey, the username is sun, and you know, gives you some information that might be helpful later on. But you know, those are the kind of 3 expected outputs that you might see, and it's kind of just iffy whether or not you get them, whether or not you cause an error to get spit out server side. It was more of an unpredictable thing. So we didn't get it in this case, which is unfortunate, but that's why I had the documentation up here from my write-up to show how this is how this could have looked, or how this looks sometimes. But I digress. This is what we're working with. So we need to get a shell now. We know it's being evaluated. We should just be able to pass in some code and see what happens. And we're going to go straight for the kill since I know this will work. There's a lot of things you could have done. I know many people pulled down like Node.js shells. There's like a GitHub repo that has a bunch of different kind of reverse shells that you can throw at stuff, and that's actually great. In fact, I feel like that one's more stable than what I'm about to show you guys for the intended solution. So hopefully you guys learned about those and checked those out and did that. But if you didn't, if you did that and you didn't do what I'm about to show you, I'm gonna hopefully teach you something new about MSF Venom. So MSF Venom actually has a Node.js payload built in. Okay, so I forgot exactly what it is. So let's do. I don't even need to run this as sudo. I don't know why I am. Ah, here we go. Here's my auto-completed version. All right, so Node.js shell reverse TCP, and our local host is that, and our local port that we're going to listen on is leet, and then we're going to output this to shell.js file. So this is awesome. MSF Venom has this built in. You know, I like to do things OSCP friendly. This isn't an OSCP journey series video, of course. This is an offhand one, but I always like to keep it OSCP friendly as I'm building up, and I don't like to use Metasploit too much. In this case, we are using Metasploit in the kind of allowed fashion for the OSCP, and this is one of the payloads that would be allowed. It doesn't have an interpreter. It seems like it's good to go. But we are going to have to edit some stuff about this. One really, really minor edit, and that is going to be this. So we need to replace all single quotes with double quotes. And the reason for that is our JSON string here has double quotes around it, and we don't want to interfere with that. We want to keep everything good. So we replace those, and now what we can do is cat our shell.js. Copy this, then our raw.cookie, and we will paste this in. Looks good. All right, and now we'll base64 encode the raw cookie into our new cookie, and now we need to start up a Metasploit handle. So we'll say sudo msf console. Let MSF console start up. While we're over here, we'll cat out our new cookie. Nice big old long string there. All right, now we're going to say use exploit multi-handler. We're going to set our payload to Node.js shell reverse TCP. Set lhost to 192.168.2.186. That's us. Set lport to 1237, and exploit that as a background job. All right, now we can take our kind of our new cookie, and now when we refresh this, hopefully we'll get a shell back. So we'll refresh. That looks good, I guess. And it looks like we have a shell. We actually have 2 command sessions open. So as you'll see very shortly here in our when I get to poke around in the server.js code, these command sessions both open. The first one is actually a dead shell that doesn't do anything, and the second one is a an actual shell. So I'll kind of show that real quick. So if I interact with session 1, there's nothing to it. We'll kill it. But if we interact with session 2, we are the Sun user, and we actually have a shell. So I actually don't care for the shell too much. It's great for a regular shell, but I want to have something that's a little bit more interactive. So if Python is installed, and it is, and also Netcat should be installed, but the thing about Netcat is that this is the OpenBSD package, so the Unix variant, so it doesn't have the TAC-E flag. There is a workaround with this that is available pretty openly on like Pentest Monkey Virtual cheat sheet, which is where I'm about to actually go. But I've had experience testing on this box with that, and you get mixed results. Sometimes usually always get a shell back, but sometimes you have to like type things in 5 times before it gives you a response. So we're going to go to Pentest Monkey Virtual cheat sheet, and we're going to go snag us a Python shell, because I found this one to be a bit more stable. So come over here and temp, and we will go, need to find 10. All right, there we go. That's not what I wanted to do, but that'll work. All right, put in RIP 68.2.186. And essentially all I'm doing here is handing off a shell to our netcat listener. So we'll grab this, and we'll start ncat, and we'll listen on 41338, and we'll paste this over here. Okay, that didn't seem to work. 92.168.2.186. Huh, interesting. Looks like we were having some technical difficulties. Alright, we'll go figure that out real quick. Alright, so we had like a really weird issue there, not sure what was going on. But I got our shell back, no problem. So let's try this again. There we go. Now we got our little Python shell. What we can do from here is spawn a TTY. That's the other reason I want to do this, because I'm going to have to interact a lot with some files on the system. So if I need a TTY, that's useful. So we can say python-taxc import TTY, TTY.spawn /bin/bash. Awesome. So now we have a TTY. I would enable autocomplete on this box, but I'm having some issues on my little Arch setup or whatever that makes that somewhat difficult for some reason. Actually, you know what? I'm going to try one more thing. So let's go into bash. Drop into bash real quick, and we can say sty raw minus echo, and exit foreground. Okay, that didn't work. I've been having some issues with that. I think it's because I'm using fish, but that's neither here nor there. We've got a nice TTY now. That was the more important part in the autocomplete. Alright, so now we're on. We are the Sun user, and we're looking at the server.js code. So also we, before we kind of dive too deep into that, I know I said I wanted to, let's go in documents, and we can see our user.text. So there's a flag. There's also the script.py. Keep note of that because we'll come back to that in a minute. Alright, so now we'll say server.js. Alright, so let's walk through how we got this foothold on the code now that we're not blind anymore. We've got our server.js here, so this is actually what's running the web server. We can see that if we do a ps ps grep for server, or not. I don't know why that's not showing me what I want to see. Very interesting. Alright, I digress. Back to the server.js. So, you'll see this code looks very, very similar to the code in the article. Actually, it's almost one-to-one. There's a few things that changed. Obviously, there was the challenge of the 404, so let's talk about that first. So, whenever you request the route of slash, which is your index, I do a check to see if you have cookies, if you have a cookie set. If you don't have a cookie set, I set a cookie for you, that is that default cookie, and that we had from the start, and then I return a 404. It's not a real 404. The page was actually there. It actually existed, and we set a cookie, and we told you there was a 404. But if you revisit the page, now that your cookie is set, it'll check and see if the cookie's set. Now it's set, and then from there it will base64 decode it, unserialize the JavaScript so we can use it, assign it to the variable object, check if the object username exists. If it does, it'll say, hey, evaluate object num plus object num, which seems like what we're saying is eval, do 1 plus 1 or 2 plus 2, right? But the issue is we're passing that JSON value as a string, and we're not enforcing a type. So it's actually concatenating those values, not adding them. So the eval just concatenates them. And then we'll output that, and that's why we get what we see. Hey, dummy, 2 plus 2 is 22. That's what we saw by default. If the username is not set, then an error occurred in value username type. So that's like if you played around with the username and just deleted it, that was just kind of like a red herring to throw you off. So yeah, what's happening here is you have this serialized unserialized string, which is part of this module, which does have that vulnerability allegedly, but I couldn't get that to work when testing. Even though I thought my goal here, I was researching Node.js RCEs and Node.js vulnerabilities, and I found that one, and I was testing it out and playing around with it, but I guess I just didn't have the right version of the module. I don't know if it's ever been updated or what the problem is, or the vulnerability could still exist and I was just doing something wrong. So I got it in my head, hey, I'm doing all this research. Let me turn this into a challenge and see if I can make it kind of tricky. And so that's what I did. And the actual eval you're exploiting here isn't necessarily this. It's actually this. And that's why you get 2 shells back, because if you notice, that reverse shell that we generated was actually an anonymous function. Let me pull up a new pane here just to kind of show that for you guys. So this is actually an anonymous JavaScript function that will execute itself. So it's an anonymous function, and then once it's done being defined, the interpreter will hit these parentheses, and that tells it to, hey, go ahead and execute. So what's happening here is it's getting executed twice, but the second execution is the only one that actually gives us a valid shell. So that's why we got that double shell kind of madness going on over in interpreter, right? So hopefully that makes sense to help you understand the challenge a little bit better in terms of getting user. Now let's try to get root. Okay, so there's a couple things we can do. I like to, the first thing I always do now is check and see if what my sudo permissions are. In this case, we don't know Sun's password, and it's required. There's nothing that we can really see. The next thing I do is kind of like to see what's going on in my local directory, and I see this output.txt is read write root, and it's owned by root. It's completely owned by root, but we do have read permission to it, and it says script is running. Okay, so we have a file that is the output of some script to let us know script is running, and it was last updated at 1955, which was like 3 minutes ago or 2 minutes ago, whatever my clock says up there. So that's clearly different from all these other things that were updated on September 19th. This was updated on October 21st at 1955, which is a couple of minutes ago, right? So that tells us this is a job that's probably running, and that this script is executing, getting ran regularly. Now we could run something like Linux enum or something like that and go further from there, but I'm going to go back to that script.py that I saw in my documents folder and see what permissions I have to it, and also check out what's inside. Script is running. Alright, so there's kind of a correlation going on here. So maybe this script is being executed as a job by root and outputting that output.txt. Well, if that's kind of the assumption you came to, you would be right. So what we can do to kind of test that theory is overwrite that script.py and do some testing. So in this case, I'm going to say id and the reason I'm doing this with echoes all like inline ghetto is because I don't trust Vim in this instance. I've done plenty of testing. Like I said, this is like the 4th or 5th time I've recorded this video. This is the best way for me to do it. All right, so now we can say ls tac l, and looks like that script just got executed. So maybe we hit it just in time to see if our output rendered, and it actually did. So it looks like it's running, I guess, every 5 minutes, because the last time it ran was 1955. And I say I guess, I'm acting over here. It runs every 5 minutes for sure. And so we got it just in the nick of time, and it is executing as root, and we do have command execution and control over the script. So now what we would want to do is kind of similar thing. We'd want to get our reverse shell going. So I'm going to do something really, really ghetto, and it's going to be okay. So I'm going to go over here to our temp. That was actually our shell. It probably would have been better to name the shell. We want a root shell. So we're going to go over 9,000 because it's a root shell, right? What I'm going to do here, instead of spilling out all this Python, I'm going to copy this, start an cat listener on port 9001. I'm going to then echo os.system over here. That's actually not what I want to do. Abort. It is what I want to do, it's just not the way I wanted to do it. I want to better define these parentheses, or quotes, whatever. Alright, bang, 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 script.py. And now let's cat script.py. That doesn't look good. Oh no. Uh-oh, spaghetti-o. Alright, so that's not what we wanted. Oh, I'm such an idiot. Alright, let's remove script.py. I know why I did that. I was thinking of the wrong thing. You'll see. It'll be very clear what my dumb brain was thinking just now. Okay, so I actually want to go back to PinTestMonkey. I want to not do that. I want to get that netcat shell I was talking about, because the netcat shell doesn't work well from the Node.js shell handing it off, but it does work well for the purpose of this script. All right. So let's vim temp2. Oops. And give this our credentials that we want, or not credentials, server info, listener. That's what I'm trying to say. All right. Cat temp2. Snag this bad boy right here. Start a listener. Echo. Quest, that's system. Script.py. Cat script.py. Looks fantastic. So now we just have to sit and wait for our script to run, which should be in 2 minutes. So I'll fast forward this until we get a shell. Alright, looks like it just ran, and it looks like we got a shell over here. So who are we? We're root. Let's go ahead and get ourselves a TTY. So import pty, pty.spawn /bin /bash. Fantastic. So we are root, confirmed root, and there is our root.txt, and that's the box. So the root privesc was extremely easy, and I kind of breezed through that because it was so easy. So the hard part of this box was the foothold, getting user, and then root was fairly easy. However, there was an unexpected difficulty, and this is probably what I've learned from the most as far as challenge design goes. There's an unexpected difficulty with the design of gaining root that made it difficult, even though the actual kind of, scale of difficulty as far as actually getting root is clearly not that hard. The way it was designed is that you have a lot of people attacking the same box on the same server, same instance, even in the context of Hack the Box where there's multiple instances, especially on the free tier. Everybody is hammering this box, and even if it's just 2 people that find out what the root privesc is at a similar time, they're going to be overriding each other's script.py file. And there's the case where multiple people figured out what the privesc was at similar times, and they were all overriding the script.py file at similar times, causing the other users' root privesc items to kind of fail. And that made it very frustrating and difficult. It wasn't a well-designed challenge for multiple users. It was fine in context of one user. As see, we went through this. It was good, straightforward, made sense, hopefully. But for multiple users, if you're battling for who gets to run the script.py first, or whose code runs in script.py first, then it's a hard time. And of course, nobody's going to be courteous and append their stuff to the bottom of the file, especially if somebody does some kind of crazy stuff to get a shell back or whatever, rather than something simple like what I did. So yeah, that was a major takeaway from me, that it was a huge oversight that I didn't get to see until it was in action. And so moving forward, next time I design a challenge for Hack the Box, I'm going to keep in mind that multiple people are going to be hitting this thing. So any method that is a requirement for gaining a shell or root or whatever needs to be accessible by multiple users, or needs to be purposed in such a way that single users is necessary and feasible in the context, which I don't see happening very often, but that's kind of the mindset you have to take. So that's, if I can share anything with you guys, it's that. Learn from my mistake there. That was one of my biggest takeaways. So yeah, with that, if you're looking to design a challenge, it's pretty simple. Pick your base OS, start up a virtual box, design all the services and everything that you want. You can implement known vulnerable applications, design the challenge and put together whatever you want. Make save state once you've got your base configuration done and all the pertinent things cleared. And from there you can export it and upload it, and that's kind of like the whole premise. They do have a more formal process where you'll fill out some information, you've got to generate flags, etc. All that's on the Hack the Box submission, challenge submission page. But as far as the practicality of doing it, it's just making a virtual machine. It's not that hard if you've got any kind of experience, and if you don't, it's a great opportunity to learn how to create virtual machines. So yeah, I hope you guys enjoyed Celestial. I hope you guys continue to play it for those of you who are in the VIP tiers. It was a fun box to make. I hope it was a fun challenge to solve, despite some of the kind of multi-user difficulties. Thanks to everyone for your kind words, support, feedback, critiques. It's all been helpful. I enjoyed it. I definitely am listening. Don't think I'm not. I read through that stuff often, and I reply as much as I can. I will have more OCP Journey videos soon for those of you watching that are here for that. For the rest of you, yeah, thanks for checking out the video. Drop a like and subscribe. See you next time.